We are almost done. We are down to our last few types of equations. These can be a little bit complicated though, so just bear with me as we go through it. If we have an equation with a radical or a radical exponent, we're looking for the real solution. And if you follow these steps, you'll be successful. First of all, and always, simplify your equation if possible. Any simplifying you can do will make your steps easier. The next is to isolate the most complicated radical on one side of the equation. And we'll see that in just a minute. But basically, you want to get a square root by itself and the nastiest one to make it easier. Then we're going to raise both sides of the equation to the index of the radical to eliminate it. Basically, what we're using is the fact that we know that the nth root of x raised to the nth power eliminates that radical. So that's what we're using. And then we have to check for extraneous solutions because the nth root of x may have a restricted domain where x itself does not. So we always have to check. Okay, let's look at an example. We have one radical here, so the first thing we do, and following those steps, is to isolate the radical. And so I'm going to bring the 3 over to the other side. And then secondly, because our index is 2, I'm going to square both sides. And so I get the square root of 3x plus 1 squared equals x minus 3 squared. Okay, now why did we isolate the variable? For just this purpose. When I square, now that I've isolated that radical, I get 3x plus 1 on one side of the equation. The radical's gone. And don't forget the FOIL method or the special product when you're squaring. It's going to be x squared minus 2 times 3x plus 3 squared. Do not forget you're multiplying out. Don't forget the special product. You don't want to know how to do the method and mess up because you write that as x squared minus 9. Okay? So once we've done that, I'm going to then go through and just solve as normal. I'm going to get 0 on the left side of the equation so that my x squared term remains positive. So 0 equals x squared. And if I go back and just rewrite this, I can see that I'll get x squared minus 9x and bring the plus 1 over, and I guess plus 8. And that's an equation that I can solve by factoring. If factoring doesn't work, I now have the quadratic formula that I could use, or completing the square if you were really ambitious, and solve it that way. But in this case, I can factor, so it looks like I have two options, x equals 8 or x equals 1. Now I'm not stopping here though, because this equation could have solutions that the original does not, because we have domain issues here, no domain issues here. And so what I have to do next is check. And I simply take each of my possible solutions and put them back in the original radical to see if it's a real solution. Okay, so I'll start with x equals 8, and I get 3 plus the square root of 3 times 8 plus 1. And the question is, does that equal 8? Okay, every x is being replaced by 8. So I get 3 plus the square root of 25, and that is equal maybe to 8. Let's see. 3 plus 5, yes, does equal 8. So we have a real solution. X equals 8 is not extraneous. Okay, let's try x equals 1. Again, I go back to my original equation and plug it in there. So it's 3 plus the square root of 3 times 1 plus 1. And the question is that equal to 1? Okay, I'm replacing every x with 1. So I get 3 plus the square root of 4, is that equal to 1? Well, clearly not, because I'd have 5 equaling 1. No. So this is not a solution. And my final answer is x equals 1 only. I'm sorry, x equals 8 only. X equals 8 only. Okay, x equals 1 is extraneous, so 8 is the correct solution. Okay, thank you. Now, let's look at another example. This time we're starting with a rational exponent, but we do the same thing because we know that a rational exponent is really saying the cube root, that's our index, of x plus 3 squared is equal to 4. Okay, so the first step is to isolate the radical, which it is in this case. So then we just cube both sides, because cubing the cube root will eliminate it. So we have the cube root of x plus 3 squared. Cubing that equals 4 cubed. Okay, and so I get x plus 3 squared equals 4 cubed, which is 64. Now that's an equation that I can solve just by using our square root property. So we just solve by taking the square root of both sides, and we get x plus 3, and remember that is equal to plus or minus the square root of 64. So x plus 3 equals plus or minus 8. And now to find the actual solutions, I see that that's the same as saying x equals negative 3 plus or minus 8, and so I get two options. X equals negative 3 plus 8, which means x equals 5, or x equals negative 3 minus 8, in which case x equals negative 11. Okay, you see how that works. There are two options, negative 3 plus 8, negative 3 minus 8. Okay, what we need to do next is check. All right, so let me check. And I'm going to check each one back in the original equation. So x equals 5. I go ahead and put 5 plus 3 to the 2/3, and that's 8 to the 2/3, and we know that that is 2 cubed to the 2/3, which is equal to 2 to the 3 times 2/3, which equals 2 squared, canceling those exponents, which is 4. And that checks, because that's what we want. We want it to equal 4. Okay, so that is a legitimate solution. All right, x equals negative 11. We substitute negative 11. That is negative 8 to the 2/3. And that is negative 2 to the 3rd power to the 2/3, which is negative 2 squared, multiplying those exponents, which is also 4. So in this case, we have two solutions that both work. So x equals 5 or x equals negative 11, and both are legitimate solutions. Okay? All right. So now let's see what happens if I have two radicals. Okay? Now here's where the first instruction, which said use the most isolate the most complicated radical, that's where it comes into play in this example, because I can do it either way. I can isolate either radical, but my life will be easier if I get the hardest radical by itself. So my first step is to isolate the most complicated radical. And you'll see why as we work our way through this problem. Okay, now this again, we have square roots, so we're going to square both sides. X minus 1 plus 2, the quantity squared. And on the left-hand side, we're good. We have 3x plus 1. But on the right-hand side, we have to use our special product. So that'll be the square root of x minus 1 squared plus 2 times the product of those terms, plus the second term squared. Okay, you've got to use the special product when you're squaring. And what we see is that we have not eliminated the radical yet. We've eliminated one of them, and we've eliminated this one because the square root of x minus 1 squared is just x minus 1, but we still have a radical term. Okay, so looks like 3x plus 1 is equal to what? X plus 4 square roots of x minus 1, and then plus 3. Okay, so this is the equation that we're looking at now. That's the equation we have to solve, so now we have to go back and do the same process. So we need to isolate the variable again. Isolate the radical again. Okay. So we'll bring everything over to this side to keep that radical positive. So I'm going to get what? 2x plus 2 equals 4 times the square root of x minus 1. Okay, 2x plus 2 equals 4 times the square root of x minus 1. Okay, and let's see. I'm sorry, I have a sign problem here, don't I? Because when I bring that plus 3 over, it's minus 2. Sorry, I've been doing a lot of taping at once, so it's easy to make a mistake. But I think I caught it. That should be 2x minus 2. And notice that I can factor okay, and I can simplify. So x minus 1 equals 2 times the square root of x minus 1. So simplify as much as possible. Dividing by 2 definitely makes our life easier in this next step, because what do we do again? We need to square both sides. So I get x minus 1 squared equals 2 square roots of x minus 1, that quantity squared. And again, this is going to be x squared minus 2x plus 1. And here we get 2 squared, which is 4, times x minus 1. Don't forget to square both the 2 and your radical. Okay? Be very careful about that. So x squared minus 2x plus 1 equals 4x minus 4. And so then I bring everything over to one side to solve it. I get x squared minus 6x plus 5 is equal to 0. Okay, and as you can see, it's really easy to make a sign error or just a multiplying error. Just double check your steps at each stage as you're going along. Let me make sure I did that right. It's x squared minus 6x, and that will come over as plus 5. Okay, and then I know how to solve that. I can factor. So I have two choices, x equals 5 or x equals 1. Now again, I have to check because I don't know that they both work. In this case, I squared twice, so I could have introduced extraneous solutions along the way. So let's see, if x equals 5, we put it back, go back all the way to the original equation, and let's see if it works. The square root of 3 times 5 plus 1 minus the square root of 5 minus 1 is equal to the square root of 16 minus the square root of 4, which is equal to 4 minus 2, which is equal to 2, which is the right side of that equation. So that one works. Okay? And then we have to check x equals 1. Same thing. Square root of 3 times 1 plus 1 minus the square root of 1 minus 1 is equal to the square root of 4 minus the square root of 0, which is 2 minus 0, and that does equal 2. So in this case, even though we did two squaring steps, both of our solutions work. So our solution is x equals 5 and x equals 1. They are both legitimate solutions to that equation. Okay.